Hey guys, so today we are going to finish our notes on matter. So the last thing that we talked about were chemical changes. So it was the change in color, change in energy, change in odor, and the formation of a gas or a solid. And today we're going to talk about the conservation of mass. So let's actually change conservation of mass. So like the name sounds, conservation or conserve means it's staying the same, right? We're not changing anything. So the conservation of mass states that while things may change appearance, or composition, during physical and chemical changes, one thing remains consistent, and that is the amount of matter present. So even though things might change the way they look, the mass doesn't go away, right? So if you take food dye and you put it in water, it's still water. It still has the mass that water had prior to the dye being put in, right? But it is it's still water. It's still there. So just because we change things chemically doesn't mean that the mass changes, okay? So the theory of this is just that the atoms are just rearranged in different forms, right? They're the same atoms, they're just rearranged differently. That's all. So when we are talking about changes, there are two terms that I want you guys to remember, okay? So we have reactant, which is a substance that is changed in a physical or chemical reaction, okay? That is the reactant. The product is the resulting substance. Of a physical or chemical reaction. Okay, so in the example I gave earlier with the changing the color of the water, right? The reactant is the substance that is changed, so that would be the water. The product is the resulting substance. So it would be, say we use red food coloring. The reactant would be the clear water, and the product would be red water. Okay, does that make sense? So, other things that you should know for physical and chemical changes are, we need to know what the different states of matter are. And you guys should know this pretty well. It's been covered a lot in all of your science classes in every grade. So we'll just touch base on it. I'm going to make you a little chart. Oh, I just threw my pen. Sorry. I'm going to make you a little chart. Something that'll make it easy for you to remember. But you should know that matter is usually found in 3 different states, right? So we have a solid, a liquid, and a gas or vapor, right? So all of these things have different characteristics because the particles interact differently in each one of these states. So in a solid, for instance, the particles that are in a solid move. They just vibrate, and they move so slow because they're so tightly packed in together. That's what creates the solid. In a liquid, these particles are going to move faster. However, they are still together. So the particles, they move around really fast, but they'll still stick with one another. Okay. So a term that I want you to remember for liquid is viscosity. And viscosity is the resistance to flow. Okay. So the speed at which a liquid moves around depends on its viscosity, right? So if you say liquid water, for example, has high viscosity, while table syrup, like pancake syrup, has low viscosity, okay? So I'm going to make you this little chart here so we can remember the characteristics of each of these states of matter just a little better, okay? So we'll make 3 little sections here, right? So we have solid, liquid, and gas or vapor. Okay, so a solid is going to have a fixed shape and volume. Okay, and let's make a little label up here. So we'll say state, features, and movement of particles. Okay, so a solid has a fixed shape and volume, and the particles vibrate, but it has a fixed position, meaning it's going to stay in that shape, right? A liquid, the shape can change, but the volume is fixed, meaning if you have a cup of water, it's a cup of water, right? It doesn't matter what you pour it into, it's still a cup of water. Volume is fixed, but water can flow, right? Liquids can move around. So the movement of particles would be free moving, and there's no fixed position, right? Because it can go wherever it wants to go, as long as the container is open. So a gas has a shape and volume that's not fixed, okay? And the volume is fixed, right? Because there's a certain measurement that there is. Actually, let's not say that. That's not true. The volume is not fixed. I don't know why I just did that. Don't mind me. I'm having a day. The volume is not fixed, right? Meaning if you take gas and you let it into the air, it will spread itself out evenly and then disappear. So that would mean the volume is not fixed. And much like liquids, gases can flow, right? They're not restricted by the same restrictions as a solid. As far as the movement of particles, these particles move quickly, right? Because gases move really quick and the particles are far apart. Okay, so the last little bit that I want to get to is phase changes. Okay, so the state of matter something is in is not permanent, right? Things can change. So we have phase changes. So we have melting. You know what melting is, right? It's when matter changes from a solid to a liquid, right? So we take our ice cube and we leave it out on the counter in a glass, and it goes from solid ice to liquid water, right? And then freezing would be the opposite, right? This is when matter changes from a liquid to a solid. Okay? And then we have vaporization. So vaporization is when a liquid turns into vapor. Okay, so when a liquid turns into a vapor, it's vaporization, right? So when you are outside and it's really hot and you start to sweat and then your sweat disappears and it dries up, it turns into vapor, right? It's vaporized, it's evaporated. So evaporation happens slowly, right? And it's only at the surface. So if you have a pond and it heats up, the part that is heating will evaporate or vaporize, right? But the layer underneath is going to not change. Does that make sense? I hope that makes sense. And then we have condensation. So condensation is when vapor turns to liquid. Okay, so here, think about like when you get a really cold drink, right? And you have, say, you're sitting outside, it's a warm summer day, and you have a glass of lemonade. And you have cold lemonade and you put ice cubes in it and you put it in your glass and you sit your glass down on the table outside. Well, the air around the glass is going to condense or turn into water. So you're going to have little tiny water droplets that are on the outside of your glass, right? Well, that is because the air around the glass has cooled down so quickly that it turns into water. So let me draw you this little chart and then you will be done for the day. So we'll draw a balloon. Again, my artistic skills are unparalleled, I know. So here's our balloon. Okay, so we have, this is vapor. This is going to represent our gas, right? And then here we'll draw like a puddle. Okay, and this is our liquid. And then over here, we'll draw an ice cube. Horrible, I know, don't judge. And this is our solid, okay? So we have gas, liquid, and solid. Well, when a vapor turns to a liquid, that is called condensation. When we have a liquid that turns into vapor, that's called vaporization, right? When we have a liquid that turns into a solid, that's called freezing. When we have a solid that turns to liquid, that's called melting. When we have a solid that turns to vapor, this one is called sublimation. We didn't go over it because it doesn't happen very often. Usually Usually it's odd for, I shouldn't say odd. It has to be under extreme conditions for a solid to turn into a vapor. And if a vapor turns into a solid, it's called deposition, which again, that's like when glass, oh my gosh, I can't even talk. Deposition is like when frost appears on grass overnight. So it went from like cold air, which would be the gas, into the frost, which would be the solid. Okay, guys? So just make sure you take all these notes so that way you have them for your quiz. And if you have any questions, let me know. And if not, I will see you in the meeting.